This video demonstrates economic order quantity. I'm using data from problem 12.12 at the end of chapter 12 on inventory management. We have a purchasing manager here who buys an inventory item. Economic order quantity is used to manage inventory that we purchase from somebody else. Such as a raw material or even from a retailing standpoint. It's not something that we produce. We'll take a look at that in the next video in regards to production order quantity. How much should we produce and at what point should we stop production? This is ordering it from somebody else, and so we'll also talk a little bit about reorder point. Here's the data, and I've used the notation, and this corresponds to the formula that is provided on the formula sheet. We have annual demand of 6,000, so this we use 6,000 of this particular item in a year. The price we pay, or the cost of that, we usually use a P to designate that. Is $100 is the cost we will pay for each item of that inventory. H is the holding cost. This is the cost of, or the carrying cost, but we use the letter H to designate that. So if they refer to carrying cost, the cost of holding inventory, this is the insurance, the storage, those type of things. It's $10 per item. Now, every once in a while, they will tell you the holding cost is a certain percentage times the price, and oftentimes that has to do with the insurance. And so the more expensive an item is, the more you will pay in holding costs because they're insuring that. And so sometimes holding costs will not be constant. It will be dictated by the price of the item, and it'll be a certain percentage, and you would simply take that rate multiplied by the price, and that would give you the holding cost. And the last thing you need for economic order is the ordering cost. Now, we don't use an O here. I think it's because we don't want to confuse that with a zero. And so they refer to this as setup or ordering cost, and we use the letter S. And so let me show you the formula on the formula sheet. And this is what you have here. This top one is what we call economic order quantity. And so you'll see all the letters we talked about: 2 times the demand, the annual demand, times the ordering cost or the setup cost. Every time we order it will cost us so much for shipping, for processing that. And we divide that by the holding cost or the carrying cost, the cost of actually holding that inventory, and then we will have the square root of that. The purpose of this is to minimize both the holding and the ordering cost. So if you were to not use this and just reduce the number of orders so that we would reduce the ordering costs, well, then you would pay more in the holding because you would be ordering less, but you would have to hold more inventory. Or vice versa, if you were to reduce you would make lots of small orders, you would reduce the holding costs, but your ordering costs would go up. And so the best order, or the best way to do it, is to use this formula, and where we got economic order quantity, where both the ordering cost, the setup cost, and the holding cost are equal to each other, and they are minimized. So let's go ahead and calculate what the economic order quantity, and then we'll talk about some of these other ones because they want you to figure out the total cost of that inventory. And so we will be looking at this one. This other formula here is for production order quantity, and this is what I was talking about. Sometimes the holding cost is not constant. It has to do with, it's a certain interest, a certain rate times the price, P. And so we would have to calculate that out. So the holding cost, and you'll see that the formulas vary based on that. And so instead of just having a constant holding cost, we would take that rate times the price, and that would then be our holding cost for H. And so you have all those variations here. So let's go back and do economic order quantity. And so once again, I'm going to do this in multiple cells to make sure that it does it correctly. We'll label this economic order quantity. The first thing I'm going to do is I'm going to do the top part of the equation. So it's 2 times the demand times the setup. or the ordering cost in this case. So 2 times 6,000, which is our annual demand. We use 6,000 of these inventory items at times the setup, and we'll have then that answer. We're then going to divide that by our H. So we're going to divide it by our holding costs. In this case, our holding costs are constant. They're not a percentage of the price. So we'll just divide by H. And then this last one is the square root. Remember, you have to call up a function. You take the square root of that answer, and that gives us 189.73 units. We'd round up. We'd offer, of course, you could not order 189.73 units. Now, when you're doing your calculations, it may be more appropriate to actually use the decimals because of the mathematical equation. But in all practical terms, we would order 190 of these units at any one time. But to do our calculations, we need to use at least 2 decimal points in our calculations. They want to know what the average inventory is. Now this one is kind of interesting. So the average inventory is simply the economic order quantity, because you're basically going to order 190, and so the maximum amount of inventory you'll have at any one time is 190, and the least amount of inventory would be 0, and so the average inventory is that halfway point. So I'm going to use this in the calculation. Even though we would order 190, I'm going to use these calculations, and we divide that by 2. We want to know where the halfway point is. So we would say that the average inventory, so between our maximum and our minimum, the highest possible is 189.73, and 0 is the minimum. The average inventory is 94.86, or 95 units of inventory. That's our average inventory. Sometimes we have more, sometimes we have less, but you simply take the economic order quantity and divide it by 2. They then want to know what is the optimal number of orders per year. Number of orders per year, so we'll just put orders per year, and we will calculate that out, a number of orders per year. What you want to do here is, this is, if you understand these equations, we're going to use 6,000 in a year, and if we use our economic order quantity, we will order this many, that much every time. And so we are going to order 31.62 times. So right around 31 times in a year, 32 if we count into the next year. But every time we order 190. We need 6,000 a year, so that's approximately 31.62 orders per year. They want to know the optimal time or days between orders. So days between orders. What you can do here is you can simply, they tell you in here that they focus just on, it's a corporate operation, so they just focus on 5 days a week, and there's 250 working days per year then. So they're not open on Saturday and Sunday. It's an insurance company. So 250 work days. And so if you look just at work days, if we know that we're going to order 31.62 times and we have 250 work days, we would simply take 250 and divide it by the number of orders we're going to make. And that would tell you that approximately every 7.9 work days, we will make another order. So kind of to summarize this, so every 8 days, every 8 work days, we're going to make an order of 190, and that will mean that we will do 31 orders per year. They want to look at the cost of the inventory. Now here's where you go back to just the cost of managing the inventory. So cost of inventory management, we'll figure this out here. And this is where I'll go back to the formula sheet. The cost of the inventory is simply this. We're going to take a look and say how many orders did we make per year, times the setup, and times the, or we're going to add to that the average inventory times the holding cost, and that's the cost of managing it. Later on it asks for the total inventory cost plus the cost of actually purchasing that inventory, and so you'll see that we just added to that the cost times the demand. And so let's go ahead and use that formula, that top one, just to figure out the cost of managing the inventory. And so I'm going to actually do this in two parts so that you can see that these numbers are equal to each other. And so as we said, we are going to order 31.62, so I'm going to take that. That's the number of orders. Now remember, we calculated that by taking the demand and dividing it by our economic order quantity, and that meant that we're going to order 31 times. Remember that every time we order, we have to pay $30 in ordering or setup cost, and so you'll see that that comes up to $948. Those 31 orders times 30. $949, $948.68 to be more precise. Now I want to show you in regards to inventory, the holding cost is based on average inventory, so that this quantity divided by 2, what's the average, what's the halfway point between the maximum amount and the minimum amount, times, as we pointed out here, the holding cost, because you basically, sometimes you have more, sometimes you have less. The holding cost or the carrying cost is $10. And you'll see that what I was talking about, this, the ordering cost is equal to the holding cost. And those points have both been minimized. So going back to this idea of economic order quantity, if I were to try and reduce my ordering costs so that I would make less orders, this would go down, but this would go up, and together they would be more expensive. Or if I were to do the opposite, I would say I am going to try and reduce my holding cost by not holding as much inventory and make really small orders, so my ordering costs go up, this would go up, this would go down, but together they would be more expensive. This is the economic order quantity where both of these are minimized. And so the cost is, of course, these both together, this plus this, and so that gives us $1,897.36 is the cost of managing the inventory. If we were to add in then the cost of the total annual inventory cost, that's where we add in the price. Let's the annual cost of inventory. In addition to the management of the inventory, we would have to add in the cost of the, so we use 6,000 of these in a year, and we pay $100. So we're going to wind up with 600,000. And so we would add that then the cost of the product plus the cost of managing that inventory. And so the cost, the annual inventory cost would be $601,897.37. One last thing I wanted to talk about that you will have in yours is the reorder point. It talks about in 1212, it talks about it takes 5 days for an order to arrive, and the demand for 1 week is 120 units. And that's 1 week, meaning 5 work days. Here's how you would normally calculate it if you didn't know. What you would do is you would take the time basically that you have here. So I'm going to take then the 6,000. I'm going to just do this over here, even though this question doesn't ask for it. The annual demand, and I'll divide it by the number of work days because I want to know how much I use per day. And so remember, there's 250 work days, 5 days a week throughout the year. So I use about 24 of these items every day, every work day. 24